So this is a quick video recap of what we did in class today on November 4th and the correlation data graphs and weight and space assignment. So the first thing you're going to do is you're going to click on Canvas and you're going to go in and you're going to find My Class. And when you get to the home page, the easiest way to find today's assignment, there's two ways. You can click on Modules and then scroll down here to today's date, 11/4, and click the correlation graphs, weight and space. So you can find it this way, and it's just right below the assignment you did. Or if you're on here, you can just click next. So now that you're at this assignment, the first thing you're going to do is send it to Notability. So I'm going to click on the document, and it's going to open up. And then I'm going to hit the three little dots in the upper right-hand corner, and I'm going to send a copy to, and I'm going to send it to Notability. I am going to create a new note, and I'm going to make sure that it goes into the science folder. So this is correlation graphs and weight and space data. So I'm going to click import, and now that's in Notability. So then I'm going to go into Notability, and I am going to find my new note, which is right here. And I'm going to do this assignment. So this is data from our textbook about surface gravity factors. So that's what surface gravity is like, or gravity is like at the surface of the planet. And for those gas giant planets, like I said in class, that's determined by where the air pressure or the pressure is the same as it would be at sea level on Earth. So that's how they determine where the surface of a gas giant is. So we've got surface gravity for the planet, we've got mass for the planet, and radius for the planet. So we're going to look at this data and answer these 5 questions on the first page first. So the first question says, would you weigh more, less, or the same on Jupiter as you do on Earth? Well, Earth has a surface gravity factor of 1. So anything more than 1 means you're going to have more gravity on that planet, so you would weigh more since weight is just mass times the surface gravity factor. And so anything less than 1 means you would weigh less than what you do on Earth. So if I look, Earth is 1, Jupiter is 2.6. So I would weigh more on Jupiter than I do on Earth. So I am just going to write more right here. And that is the answer to the first question. Now, the second question says, would you weigh more, less, or the same on Mercury as you would on Mars? So Mercury has a surface gravity of 0.38. And Mars has a surface gravity of 0.38. So that's the same gravity factor, which means you would weigh the same. So I'm going to write same right here. It said, which planet would your weight be most similar to Earth? So we're looking for the planet where it's got the closest surface gravity factor to Earth. Venus looks pretty close at 0.91. Saturn's closer at 0.92. Neptune is 1.112, but Saturn is the closest. So the answer to question number 3 is Saturn. So I'll put that in there. All right. Question number 4 says, which planet has the greatest mass? So now I'm looking at the pink mass column, and that's clearly Jupiter has the planet with the greatest mass. So with 189,813 kilograms times 10 to the 22nd. So it's huge, it's super massive. So I'm going to put in Jupiter right here. And then it says, which planet has the highest surface gravity factor? So I'm back to the green column. And if I look at my data, Jupiter has the highest surface gravity of any planet. So I'm going to select here, and I'm going to write in Jupiter. So your answers to the questions on the first page should be more, same, Saturn, Jupiter, and Jupiter. And as I stated in class, I don't care if you write incomplete sentences or not. It's fine with me. We're just trying to make sure that we understand this data. So if you scroll down and you go to the second page, there's this graph. And you can see that it's mass versus surface gravity. So this is graphing the pink column, the mass, compared to the surface gravity. So we can look and see if there's any trends or anything going on. So as you can see here, we've already drawn in the trend line. The dot up here that's at the highest point all the way to the right is Jupiter, and the dot that is at the lowest point on the left, that's Mercury and Mars. They have the same surface gravity factor, and on this scale, their mass shows up at the same spot. So just to kind of give you an idea of what the different planets are. So if we look at this, we can see that, you know, this line is trending upwards. And so the first one says, select a claim from the following possibilities. Planet mass and surface gravity are not related. So if planet mass and surface gravity weren't related, the dots would be all over the place and there would be no trend or trend line. Well, I can see that's not the case, so it's not A. B, planet mass alone determines surface gravity. So if that was the case, all of the dots would be exactly on my trend line. They would be perfect. And that is clearly not the case either. There's some dots that aren't really, really close, and there's some, you know, that are really close to the line. So then C is, with planets with greater mass tend to have higher surface gravity, or D, planets with greater mass tend to have lower surface gravity. So if I look at this, I can see that as the line goes up, as my mass increases, my surface gravity increases. So the correct answer for this one should be C, planets with more mass tend to have higher surface gravity. So that is the answer that I'm going to select. All right, next question. Select the evidence from your following choices. So what evidence do I have for this? The points on the graph are A, random, B, the points on the graph are in a perfect straight line, C, the points on the graph show a general positive trend, or D, the points on the graph show a general negative trend. So this is a positive slope. My line is going up. So that is a general positive trend. It would be a negative trend if the line was going down and the slope was negative. So I am going to select C, the points on the graph show a general positive trend. Okay, last question for this graph. What type of correlation does graph number 1 show? So we've already ruled out that it's not negative, so I know that it's not a weak negative or a strong negative. So now I have to decide, are those points pretty close to the line or are they really far away? And as I showed you guys in class, let's take a look at the second graph. So there's the second graph really quick, and there's the third graph. So based on that information, does this look like it is a strong positive or a weak positive correlation? And the correct answer would be it is a strong positive correlation. Those points are pretty close together. So I'm going to select D, strong positive. All right, so you should have C, C, and D as your correct answers for graph 1. Graph 2 is radius versus surface gravity. So now we've graphed the data of radius compared to, which is the blue column, compared to the green column, which is surface gravity. So I'll go back down to that graph and we'll take a look at the data. You can see that it's still trending upward. My dots are a little bit further away, but there's a definite trend that as the radius increases, the surface gravity is increasing. So one claim we need to select here. So are surface gravity and radius not related, meaning the points are random? I already told you they're not, so it's not A. Radius alone determines surface gravity. We would see that if all the points fell on our trend line, and none of them do, so it's not that. Planets with greater radius tend to have higher surface gravity, or D, planets with greater radius tend to have lower surface gravity. Well, since this is a positive trend, it's going to be planets with greater mass or greater radius tend to have greater surface gravity. So I am going to select C for this assignment. And that one's kind of wonky, so let me undo that and do it again. C for this assignment. So planets with greater radius tend to have higher surface gravity. All right, next question. What type of graph is shown in 2? What type of correlation? Is it a weak negative, strong negative, weak positive, or strong positive? So this is a positive slope. The line is trending upwards, so we know it's positive. Is it weak or strong? Now, compared to the first graph, this is definitely a weaker positive. So I'm going to highlight weak positive for this trend line. All right, we're on to the last part of our assignment, graph 3. And graph 3 is looking at the radius compared to the mass. So how are the radius and mass related? And here you can see Jupiter is still way up there, and this other one that's kind of over in the middle of the graph, that's actually Saturn. So Jupiter's way up at the top, and then there's Saturn, and then there's the other planets, and there's kind of this random trend line drawn in there. So we need to select a claim. Planet mass and planet radius are not related. Planet mass or radius alone determines planet mass, or planets with greater mass tend to have a higher radius, or planets with a greater mass tend to have a lower radius. Well, you should know that big, massive planets with lots of stuff, they are bigger planets. So they have a higher radius. So I'm going to select C as my correct answer. And then the last question on here is, what type of correlation is this? So is it a weak negative, strong negative, weak positive, or strong positive? So we can see here that this is a positive trend line. It is headed up. It has a positive slope. And the data points really aren't close to our trend line. So I'm going to select weak positive, C, as the correct answer. And that's it for this assignment. So now I just need to turn it in. So in order to turn in this assignment, you're going to click on the box in the upper left that has the arrow coming out of it. Then you're going to select other apps, and then you're going to click on share note. So it's going to get that ready. Now I want to share it to Canvas. So I'm going to click on the Canvas app. You need to make sure that you select my class, Miss Thompson. And then for the assignment, you're going to scroll all the way to the bottom, because this is our most recent assignment, and you're going to select correlation graphs, weight in space, this one right here. So once you have that selected, you're going to hit submit, and you are completely done with this assignment, and it's been turned in. If you're having any questions about this video, you don't understand the assignment, you're still confused about correlation and positive trends, just let me know, and I will be happy to assist you. Just send me an email and I'll give you a hand.